Okay, so t-test is an inferential statistic that used to determine if there is a statistically significant difference between the means of two variables. Remember, as I said, we have one sample t-test, two sample t-tests, and then paired t-test. So the t-statistic is a kind of an inferential statistic that always tries to know if there's a statistical difference or if there is a statistically significant difference between the mean of two groups. So for you to calculate t-test, you require or you need three fundamental data, and these three fundamental data: number one, you need to have your mean values for each data. You need a mean value for each data. So like for example, in one sample t-test, this is a mean value for your test sample, and this is a mean value for the standard. Yeah. So and then after the mean value from each different data set, then you need a standard deviation from each group. You need a standard deviation, and then you also need the number of data values, that is the number of samples you use. So in the case of one sample t-test, this is the formula we use. One, we have x bar. X bar is the observed mean of the sample, and then mu is an assumed mean, which is the mean of the standard mean. That is the standard mean. And we also have n, which stands for the sample size. Then in the case of two sample t-tests, we have number one. This is the mean of the first sample, and this is the mean of the second sample. And this is the standard deviation of the first sample, and this is the standard deviation of the second sample. And then this is the number of samples used in sample one, and this is the number of samples used in the case of sample two. So these are the formula that are used in calculating t-test for one sample t-test and independent t-tests. Okay, so now we are going to look at one tell or two tell test. Of course, when you are doing this t-test, you need to know whether you are going to talk with one tell test or two tell test. So if in the case of one tell test, is actually when you only care whether the two populations are different from one another. So if you actually set in mind that the mean or the mean are different, or if you have this idea that the two populations are different from one another, then you perform two tell tests. Like for example, if you collect a data from BUK and you collect data from ABU, there are two different populations. So you use two tell tests. And another example now, assuming now you collect a data from biochemistry department in ABU here, and you go to geography, you also collect a data from geography. So you see, it's two different populations. So you apply two tell tests. But if you want to know whether one population mean is greater than or less than the other, then you use one tell test. So that is why now, for example, whenever you are calculating your t-test, and now you observe that in the case of alternative hypothesis, the standard mean or the standard mean is greater than some value, then you use right tell test. And if the standard mean is less than some value, then you use left tell test. But if you know that the standard or the standard mean is not equal to some value, then you use two tell tests. We use two tell tests. If the standard mean is not equal to some value, then of course you use two tell tests. So I think from here we can clearly understand that for you to work with right tell test, it must be, or the standard mean must be greater than some value. And for the left tail test, the standard mean must be less than some value. And in the case of alternative hypothesis for the two tail test, it means that the mean is not equals to some value. So that is in the case of one tail test or two tail test. But in more clear terms, if you have an idea that the samples you collected are from two different populations, or the populations are different, then from there you know that you are just going to work with two tail tests. But if you actually know that whether one population is greater than or less than the other, then you have to perform one tail test. Okay. So now we are going to look at the confidence interval. When we said confidence interval in the statistic refers to a probability that a particular parameter will fall between a set of values for a certain proportion of times. Then an analyst often use a confidence interval that contain either 95% confidence interval or 99% of expected observation. Like for example, when we set a confidence interval, it means that it's a probability that a particular parameter will fall between a set of values. Like for example, now assuming now you are taking a class, and based on actually the way you see response from the student, then you set a confidence interval. And this confidence interval, it means the confidence you have that when you conduct a particular exam or when you conduct a particular CA, that you are sure of that percentage. Like for example, if I said, okay, I'm 95% confidence that the student of 400 level will pass biostatistic exam with a score of 50 to 80. So the assurance, the percentage assurance you have within or between a range of values is what you call a confidence interval. That I am 90% confidence that the class rep of 400 level will get 80 to 90 marks in biostatistic exam, and that is confidence interval. And in a normal distribution curve, if you want to actually indicate the position of the confidence interval, this is where we normally have confidence interval. This is where we have the confidence interval, and this is where we have our level of significance. The level of significance, or we can just call it the critical value. So how do we calculate the area under the curve here? First, you actually said minus divided by your confidence interval divided by 2, then it will give you the value here. And here you also said 1 minus the confidence interval, assuming now the confidence interval is 95%. So if the confidence interval is 95%, it means that your C value is equal to 95%, it means 0.95. So if you have 0.95 and you want to get the value of this, that is area under the curve, what are you going to do? We are now going to set 1 minus 0.95, 1 minus 0.95, then divided by 2. Of course, when you set 1 minus 0.95, we have 0.05. So 0.05 divided by 2, then we have 0.25. So it means that here we have 0.25, 0.25. And then here is also something, 0.25. And then here we have 0.95. What we have here is 0.95. So here we have 0.995. So this is how we get, and here we call here as alpha. Here we also call it alpha. That is the level of significance for two-tailed test. Of course, from here you can see that this is a two-tailed test. This is a two-tailed test. This is to tell us that that the standard mean is not equals to some value. So it is t-tailed test. Or from your data you collected, you are sure that the populations or the two populations are different, then you use two-tailed test. And then now we are also so that is in the case of the confidence interval. Then now in the hypothesis, in this hypothesis is a statistical method that used to determine if there is enough evidence in a sample data to draw a conclusion about a population. So yeah, of course, hypothesis, in every experiment there must be hypothesis, there must be hypothesis testing, and this hypothesis testing is actually you have to provide enough evidence in a sample data to draw a conclusion about a population. And of course, you know that in biostatistics or in statistics, you cannot work with the whole of population, but you collect a samples, you take some element of that population, and that is what you call sampling. So you work with the samples, and based on the samples you collected and the statistical you can draw actually a conclusion about a population based on the sample you collected with respect to the types of sampling techniques that you use. So therefore, in a particular population, you can set a hypothesis to see if you are going to draw a reasonable conclusion about a population. And this hypothesis testing involves in formulating two contradicting or two competing hypotheses, which comprise null hypothesis and then alternative hypothesis. So the alternative hypothesis, like for example, let me just say, I want to work with mosquito. So based on my null hypothesis, I can say that, okay, maybe I want to check the presence of Plasmodium falciparum in mosquito. So I can just say that, okay, for the null hypothesis, none of the mosquitoes from Abies area is harboring Plasmodium falciparum. So that is my null hypothesis. My null hypothesis is always negative of what you want to look for. And then for the alternative hypothesis, then you now say that, okay, the mosquitoes from Abies area will harbor Plasmodium falciparum. Then you now go ahead with data collection. After you collect your data, then you analyze the data, then you now apply statistics. So based on the statistic, maybe using Z statistic, T statistic, using ANOVA, you can see if you are going to reject your null hypothesis or accept your null hypothesis. So therefore, now we are going to look at two-tailed hypothesis testing. So in the case of two-tailed hypothesis testing, this is what you call a rejection region. This is a rejection region. So whenever you make your calculation and you find out that the parameter you obtain fall within this region, so this is a rejection region of null hypothesis, and this is also the rejection region of null hypothesis. And actually, this is a normal distribution curve. So it's depend on the number of samples that you are working with. If you are working with a samples of, let's say the number of sample is greater than or equals to 30, so in this case, you are going to work with Z statistic. If the number of sample is greater than 30. But if the number of sample is less than 30, then we use t-test. We use t-statistic or z-test. We use z-statistic or z-test. So that is why whenever you are working or you are making, you want to calculate or you have your data and you want to know which types of the statistic you are going to use, number one, check if the groups you are working are two, then you actually go for, you will put at the back of your mind, you are either going to work with Z statistic or T statistic. But if the samples are less than sorry, is greater than or equals to 30, then you are applying Z statistic in that case. And if it is actually, if it is actually less than 30, then we use T statistic. And this is, of course, this is a region that that indicate that you do not reject your null hypothesis. And this is why you have your confidence interval, which is in the case of 95% confidence interval, you have 95%. So whenever you make your calculation and the values fall within this, then it means that you are not going to reject the null hypothesis. Okay. Okay, now so we are going to look at some example, but before then, let's actually stop. Then we'll meet in the next set of video. Okay.